The strategy pattern allows us to encapsulate a family of algorithms, make them interchangeable, and select them at runtime. In simple terms, it separates the algorithm from the object that uses it. Instead of recording behavior inside the class, we move that behavior into separate objects, and this leads us directly to the key idea, composition over inheritance. Let's clarify what that means. Inheritance represents an is-a relationship. For example, a car is a vehicle. Composition represents a has-a relationship. A car has an engine. With inheritance, behavior is fixed at compile time. With composition, behavior can change at runtime. Strategy pushes us toward composition, which makes our code more flexible and loosely coupled. The strategy pattern also aligns well with solid principles. First, the single responsibility principle. Each strategy encapsulates exactly one algorithm. The open-closed principle. We can introduce new strategies without modifying existing classes. We extend behavior by adding new types, not by changing old ones. That's a very powerful architectural property. Let's quickly look at the UML structure. We will start with the context. The context is the object that uses a strategy to perform some operation. It doesn't implement the algorithm itself. It delegates that responsibility. Next, we have the strategy interface. This defines the contract for the algorithm. It specifies what operation must be performed but not how. Then come the concrete strategies. These are the actual implementations of the algorithm. Each one encapsulates a specific behavior. Now, let's introduce the client. The client is responsible for selecting which concrete strategy should be used. It creates the strategy and injects it into the context. Finally, during execution, the context calls the strategy through the interface. Notice something important here. The context depends only on the abstraction, the strategy interface, not on concrete implementations. That's exactly what gives us flexibility. Imagine we are building an image processing module. We need multiple filters: grayscale, CPR, blur, maybe more in the future. If we use inheritance, we might create a base image filter class and then subclass it for every filter type, but each subclass completely overrides the filtering logic. So we don't really gain code reuse, and if filters grow, we risk subclass explosion. Instead of thinking in terms of hierarchy, let's think in terms of behavior. The core idea is simple. Filtering is just behavior. So instead of creating subclasses, we extract the filtering algorithm into a separate object. Then we inject that strategy into a single image filter class. The filter doesn't know how the algorithm works, it just delegates execution. This removes tight coupling and makes adding new filters trivial. Now let's implement this in Swift. First, we define a protocol that represents our filtering strategy. This protocol defines the algorithm contract. It says what must be done, but not how. Next, we create concrete strategies. Each struct encapsulates a single algorithm, one responsibility, nothing more. Finally, we define the context. The image filter doesn't know which algorithm it uses. It simply delegates the work to the strategy, and now we can switch algorithms at runtime. No inheritance, no conditionals, just clean composition. The strategy pattern allows us to encapsulate behavior, make algorithms interchangeable, and build flexible, maintainable systems. It's simple, powerful, and widely used in real-world applications. And that's the strategy pattern.